Pacific silverweed, or as it's known by its scientific name, Argentina egdii. Pacific silverweed's a salt-tolerant plant that is in relatively high densities in coastal and estuarine salt marshes on the Pacific coast from California to Alaska. And it's sort of interesting because it goes across the Arctic into Hudson's Bay in the North Atlantic. So we call it Pacific silverweed, but it's actually can be found in the Atlantic as well, all the way south to New York. And it's found less commonly on riversides, dunes, and beaches from low to middle elevations. So it can exist away from estuarine areas, but we typically associate it with estuarine environments on the Pacific coast from California to Alaska. So a really wide-ranging plant. And I think it's interesting because it's one of these plants that you may have seen and not really noticed or taken that much consideration of the overall importance of this plant. But to many indigenous people, it's a foundational traditional food species that's been managed and harvested for thousands of years. And we'll learn a bit about that management, and we'll talk a bit about the basic biology and ecology of this plant. We'll start with, we've got two images here. One's a photograph from Mark Turner showing a close-up of Pacific silverweed, and the second one's a line drawing of Pacific silverweed from Hitchcock and Cronquist from 1961 that was presented in Abe Lloyd's 2001 master's thesis from University of Victoria. Pacific silverweed is a herbaceous perennial with erect pinnately compound leaves. Okay, what that means is paired, basically. So we've got the stalk going up, stem going up, and there's leaves paired on either side. That's all that means, is the pinnately compound leaves on either side of the stem. In total, they're about 10 to 40 centimeters tall with recumbent stolons. Or stolons. That's these guys, runners. Think about strawberries that have the runners. This is what we're talking about. These stolons are a way for the plant to spread. It sends a shoot out the middle, comes down, and can bud off in various spots along that stolon. The leaflets alternate between larger oblong to obovate, sharply serrated leaflets. And so what that means is you've got these leaves and they're serrated along the edges. And then in between these large leaves, there's often these really small little leaflets in between. So you can have a large leaf that's paired and then a small leaflet that's paired in between them. And the flowers come on long stalks emerging from the stolon nodes. So here, if we kind of look at this stolon coming out here, budding along the way, from that same part of the plant shoots up to the flower. The flower has 5 petals and it's this kind of buttercup yellow color. And so that's a kind of a good way to identify this plant, looking for something that's like this green serrated leaves. They're kind of V-shaped here. You can see this V shape to the leaves. They're serrated, they're paired. The flower will be coming off the stolon here. That extends out as well. So there's a few things that could help us if we're in that estuarine environment and we're looking around for Pacific silverweed, what we can expect. Locally, you can find them over in Chuckanut Bay, that kind of impounded area. There's a trestle there, and there's a small salt marsh on the upper part of Chuckanut Bay. And down in the Nooksack watershed as well, kind of Murrieta area, there's some salt marshes through there that have pretty healthy Pacific silverweed populations as well. This is from Turner and Cohen, 1982, and the scientific name has changed, but this is Pacific silverweed, And this is showing the extent of the traditional use of Pacific silverweed roots by native people. The solid areas, both the darker and the grayer areas, are known uses, darker being heavy use and then lighter being less use. And then the hatched areas are unconfirmed, so there's an assumption that it was used, but at the time of writing they didn't have confirmation of that. Which is fair to say that throughout its entire range it was consumed, particularly in northern areas where camas did not grow. Kind of from here up, you've got a lot less camas, and so this would have been one of the more important plants that would have been harvested, managed, and consumed. So it's used arguably throughout its entire range, but there's presenting data here for where we knew, where we've got positive, data that it was used for food, for traditional foods. Consumption, it was Pacific silverweeds consumed both on a daily basis and also as a feast food, meaning for large gatherings, potlatches, things like that, there would be a lot of Pacific silverweed root consumed. And it was often dipped in grease, either seal grease or ooligan grease. Ooligan's a small, kind of sardine-ish shaped sized fish that returns to the fresh water to spawn. And they're harvested in massive numbers, and they're very, very oily, and so they're processed for their oil and really highly valued for their oil. And the Pacific silverweed roots were frequently dried and then cooked, re-wetted, rehydrated, and then cooked kind of low and slow. The two main methods were a pit cook, where you dig out a pit, line it with rocks, start a fire. When the fire burns down, you sweep the ash away, layer that pit with green vegetation and whatever you want to cook, and then soil over the top and let it sit for 12 to 24 hours. Pit cook you would do the other method would be in a bentwood box. And here's a traditional bentwood box, and here's a modern one that was built by Quoxie Stahl, Chief Adam Dick, and Abe Lloyd. And these are basically a way of making a sealed container out of wood that you would use for cooking. These are the traditional crock pots. So it's a wooden insulated box. The wood is providing insulation. It's watertight. Fill with water, put whatever you want to cook in there, and then throw a couple hot stones in there, and those hot stones would heat the water and cook the food over a long time. So this is low and slow. This is the tradish crock pot method, basically, these bentwood boxes. It's pretty cool stuff. And Pacific silverweed roots have one of the highest carbohydrate values of any traditional food. So when we think of traditional Salish sea foods, salmon, clams, things like that, maybe deer, come up to the top of our mind, but sources of carbohydrates were relatively difficult to find. And so things like Pacific silverweed that have a high carbohydrate value are vitally important in the traditional diets. This graph this table is a bit complex, and so we're going to spend a bit of time walking through it column by column. So these are data Abe presented in his 2011 thesis again. And these are Pacific silverweed samples that he collected throughout the year, starting in March to December. And there's a couple kind of caveats to these data. This one from 23rd of March. These samples weren't put in the freezer right away. They were left in the Ziploc baggie for a little while and kind of started to grow. So that was kind of a oops, but we're still going to include those data. Secondly, in December, there's two sample collections here, and the one with the superscript 3 are replicate roots taken on December 10th and air dried for a month after they were harvested. So here he's testing the impact of drying before consuming on the nutritional value of Pacific silverweed. Next is total starches, grams per 100 grams dry weight. So we measure the amount of starch, divide that by the dry weight of the plant, normalize that by 100 grams of dried weight, and you come up with these values. You can see some trends here. We kind of have a bit of a peak here in July, but May is a relatively low value. August, relatively low values. A little bit higher in December, but really kind of March, May look like our higher values in the amount of starch per 100 grams dry weight. Total soluble sugars, again, same measurement, grams of sugar divided by 100 grams of dry weight. More sugars in March, May, a bit of a low in July, and even lower late in the year, December. So really, for sugars, kind of earlier in the year, would yield a higher sugar percentage or sugar value per 100 grams of dry weight. TEAC, these are micromoles per 100 grams dry weight. These are TAC is basically a measure of antioxidants. So looking at the antioxidant value of the Pacific silverweed. These numbers are a bit hard to follow because there's no comma after the thousandths place. But we've got 6,000-ish, 7,000, and then the big deviation is again here in the December values with about 2,000 per 100 grams dry weight. Total tannins, which is TAE, grams per 100 grams dry weight. Here you see the highest tannins sort of in this time frame, May through August. Tannins impart that astringent taste, kind of dries your mouth out. There can be a lot of tannins in tea. There's a lot of tannins in acorns, which is one of the reasons they have to be processed so long, soaked in water and changing the water and doing that for quite a while to get rid of the tannins. And also with the phenolics here, similar sort of pattern with higher values in the summertime, kind of coincident with the higher values in the tannins. And one of the thoughts behind this is these are done to reduce herbivory. So both tannins and the total phenols over here make plants unappealing for herbivores. One of the thoughts is that Canada geese tend to be migrating or more present in the ranges for Pacific silverweed at this time frame. And so by upping the phenols and tannins within the plants become less attractive to Canada geese. So it could be something that's done to reduce the impact of herbivory. What's also interesting is there is a reduction here in tannins from drying. So if we look at the December 10th sample that was harvested, frozen, then sampled, compared to the sample that air dried for a month, there's a significant drop in tannins. Now traditionally, Pacific silverweed would have been harvested more in that late fall, early winter time frame. Going into winter, it would be a staple that would be heavily used throughout the winter. So the roots would be harvested and dried, then rehydrated and cooked, cooked low and slow, which also has the effect of breaking down the tannins, but also the act of drying it and storing it may also have helped to reduce those tannins. So that kind of makes sense that you would harvest it when tannins are the lowest, although there's perhaps a cost there, meaning that your sugars are also at a relatively low amount, although starches are still relatively high. So it's a bit of a trade-off, but it's pretty interesting to look at these data and to think about when and how Pacific silverweed roots were harvested, processed, and then stored, and then consumed. This is a conceptual diagram that Abe presents, thinking about how the traditional diets have changed, the diets of indigenous people have changed through time, and how that relates to food-related TEK, or traditional ecological knowledge. So on the x-axis we have time starting in 1800 through to 2000, and here we have two y-axes. The first one is consumption, and those things are in, I'm colorblind, I'll call that blue, could be purple, I don't know. So consumption is listed in that bluish purple color, and then food-related TEK, it's a bit hard to read here, but it says food-related traditional ecological knowledge is in red, and that's on our second y-axis. So we can come down here to our friend Pacific Silverweed, and consumption was relatively stable until the introduction of the potato, and consumption of Pacific Silverweed began to decline as potato agriculture and growth became more popular and prevalent, down to likely, for all intensive purposes, fundamental stoppage of Pacific Silverweed harvest. It was probably still going on, but not really a major portion of people's plates or their diets. And then potato became supplanted by store-bought carbohydrates. So the introduction of cheap carbohydrates began to reduce potato consumption. Now with that, there has been a decline of food-related traditional ecological knowledge around Pacific Silverweed. However, even after the harvest of Pacific Silverweed is effectively gone to near zero, there's still a fair amount of food-related traditional ecological knowledge within the community that's passed on through stories and through ceremony. And so this traditional ecological knowledge is held within the community, even if the practice isn't currently being practiced at a high rate. This is a great diagram from one of Doug Dewar's papers in 2011 that shows a kind of an unmodified, air quotes, natural salt marsh, where you've got marine species here. Fucus is a marine algae, up to low marsh, high marsh, and then our edible rhizomes, and then the transitional salt-tolerant meadow. So kind of a natural gradient in these edible rhizomes are occupying a very small part of this continuum. However, if this is really what we want, if we want to promote the growth of edible rhizomes, one way we can do that is by building a rock wall, filling it in with soil, and building a terrace at that exact height within the salt marsh that promotes the growth of edible rhizomes. These edible rhizomes, Pacific Silverweed and its allies, if they live too low, they don't survive. It's too salty for them. If they live too high in the freshwater environment, it's also not ideal for them. So things like this, I'll talk about clams this way, occupy a Goldilocks zone. Up here, it's too fresh for them. Down here, it's too salty for them. And it's just right here. And so by building this rock wall and terracing the intertidal, you can greatly expand the habitat for these edible rhizomes. And just for perspective, this I'll use this one as an example. This section here in tidal height or bathymetry or topography, depending on how you want to think about it, is really only a few centimeters, meaning the difference in elevation between this transitional salt-tolerant meadow and the high marsh might be 10 centimeters. And so when we're building out a structure like this, you have to be spot on. This has to be built to within millimeters of the optimum habitat. That if it was a few centimeters too high, it wouldn't work. If it was a few centimeters too low, it wouldn't work. So there's really a lot of knowledge that goes into creating this these intertidal, or in this case, high marsh habitats that it's really quite interesting. And you can see here this is expanding out, and of course there's an ecological cost here. If we're going to build out the edible rhizome garden, we're losing some of the high marsh and some of the low marsh plants. So this is done for the benefit of Pacific silverweed and other similar species. This is really similar to clam gardens, which is something that I've studied for the past 8 years now, I guess, for quite a while. And so it's really interesting to see how these structures can be built and modified really with a lot of intention and care. And with this, there's more than just build it and then a whole bunch of Pacific silverweed proliferate. There's a lot of maintenance that goes along with this, harvesting Pacific silverweed, removing undesirable plants, tilling the soil. A lot of care goes into maintaining these gardens, just like you maintain gardens in your backyard. And that results in an overall increase in the number of Pacific silverweed and the size of them. So this is showing a curve of Pacific silverweed biomass and arguing that by weeding, by removing non-Pacific silverweed, by removing competing species, you can get an increase in the number of Pacific silverweed and the biomass, the size of those plants as well. So it's more than just building a rock wall and letting things go wild. It's building a rock wall and then maintaining that garden. So it takes constant maintenance and interaction, again, the same way that we maintain gardens in our backyard. So that's a little bit about Pacific silverweed. Heishke, thank you. I hope you enjoyed learning just a bit about a really important species, the Pacific silverweed.